Okay, kids, let's learn about transformers and generators. Transformers, robots in disguise, more than meets the eye, right? Okay, you've seen the movie. Yeah, come on, you got it. First one, solid. It was solid. Like that, all that. You know, Optimus Prime, good guy, but come on, you don't make very good movies. I mean, come on, let's be real. All right, anyways, so what I have up here on the board, can you see that? Yeah, you can see that. We all know from watching the last video on Faraday's equation that we can generate a voltage, an EMF of voltage, by spinning some wire around and boom, 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 and getting some wireage to do that. And the more wires we have, the more loops we have, the greater the voltage, the faster we spin it, the greater the voltage, yada yada yada. So this is our flux, because I'm reviewing right now, right? Reviewing. You should know this. But what I've got up here is a different version of the Faraday equation. Sometimes this is called the generator equation. The generator equation. So this is a different version, and this part of it here, 2 pi, and this is radians per second, because we all remember that's angular velocity, radians per second. So this does have to do with how fast something is spinning around. It's just a different way of writing it. It's a derived equation. I'm not going to go through the derivation for you, but you know, you're probably bored as it is now. Only a minute and 30 seconds into the video, you're probably already going and drooling. So I'm not going to do that. But this equation sometimes comes in handy-dandy notebook when dealing with a generator. And a couple of the homework problems will have this to be needed in order to solve it. So I just wanted to point that out. So this is still the same thing on top right here. You have the number of coils, you have your field, your area, and you have your field, and there's your flux right there. And 2 pi radians per second instead of over time. So it's yeah, it's just a slightly different way of looking at it, and sometimes comes in handy. Okay, so now that we've got that settled, yeah, we'll keep this up here for now. Let's talk a little bit about what a generator is. Like I said, it's called the generator. What's a generator? What's a generator? Generator, as opposed to an electric motor. You've heard of both of these. Yes, you have. An electric motor. Okay. Well, a generator and electric motor are actually opposites of one another. They're actually the complete opposite thingy. What are you talking about? What are you talking about? A generator uses mechanical energy. Okay, so mechanical energy. Remember I was telling you about the gnomes. The gnomes were used to, before gnomes' rights, they would spin those coils of wire between the magnetic fields, and that spinning is mechanical energy. It's mechanical energy means kinetic energy. It's also potential energy, but kinetic energy, energy of motion. So when you move something or turn something, or something is moving, it has mechanical energy. So a generator uses that mechanical energy, okay, the gnome spinning that thing, that's mechanical energy, to produce electricity. Let's write that down. Okay, so the generator, okay, uses mechanical energy to make electricity. Hence, we get the lights. Oh! Gnomes spin wires between magnetic fields. Lightage, okay? That's what a generator does. So use mechanical energy to make electricity. All right, with me? Okay, I'll turn you slightly that way so you get that in. Yeah, you're with me. Yeah, you are. And electric motor is just the opposite. It's just the opposite. Back the truck up or switch mechanical energy and electricity. It uses electricity to do something mechanical, to produce mechanical energy, to do work. To do work, that's the big thing there, to do work. So uses electricity to do work, or you can just say, to make mechanical energy. Examples, to make ME, I'll put EME for mechanical energy. Well, a generator is, example of a generator. Okay. Now you have the nuclear power plant out there. The nuclear, say it right, nuclear power plant. Yeah, you have a generator there, and it's motion, spinning turbines, spinning wire, produce electricity. Electric motors, lots of examples of those. Some of you might even drive an electric vehicle. You might. That would be an electric motor. You use electricity stored in the batteries that you have to keep recharging to do mechanical work, to do make mechanical energy. In order to make motion, make the car go. Okay, all right, okay. If a car is driving down the street and it has an S painted on the side of it, an S, what do you call that? Well, you look at it and you say, look at that S car go. Especially if a snail's driving it. Snail driving a car with it. Look at that S car go. Okay. Another example of an electric motor would be like an electric lawnmower. All right, so gas-powered lawnmowers. Most people have those. Some people have electric lawnmowers or electric. What do you call those things that trim weeds? Trimmers. Weed whacker. Okay. Some people have electric tools, and those are using electricity and some battery-powered tools that's using that electricity to do mechanical work. Okay, so they're just opposites of one another. So I want to point that out. Now, let's talk about transformers. Remember, robots in disguise. Shia LaBeouf, Megan Fox. Those are the two stars. That one was decent. Number one, decent. Yeah, I didn't say great. I said decent. So, transformers. Okay, besides being robots in disguise, what is a transformer? Well, the power plant sends out electricity along those big wires that go for miles throughout the state, miles and miles. Can even go for hundreds of miles. Actually, you can send that energy out, and those big, huge lines, like just up the bypass a little bit, those are 250,000 volts. 250,000 volts, that's a lot of volts, people. That's a lot of volts. So when that voltage comes into your house and it's down to 120, what the heck happened? How did that happen? Gnomes did it. No, stop with the gnomes, okay? Gnomes, no, not anymore. Used to, but no. Now, how do you get 250,000 volts down to 10,000? Well, down to 120. Well, first you get it to 10,000. So once those big lines, that are traveling for miles along, carrying that electricity, you'll get what are called transfer stations, and they'll take that 10,000 or take the 250,000 volts and step it down. We're going to be I'm saying those words. Step it down. Step it on down. Step up. Yeah, tough guy, step up. Okay, we'll talk about stepping up. Not that kind of stepping up. But we're stepping it down to 10,000 volts. And then from 10,000 volts, those are the lines that go along the road, outside your house there, down the road that you live on. Those are 10,000 volt lines. Now, 10,000 volts has to go down to 120 volts or 240 volts in your house. How does that happen? There are transformers. You ever see those gray cylindrical things on every, several telephone poles? Do it, Pay attention. Look up at the telephone poles. You'll see those gray cylinders. Those are transformers. Okay, those are transformers as well. And they take that 10,000 volts and step that on down. And it goes into your home, and you get 120 volts. In your house, you have a transformer as well, because it actually is stepped down to 240 volts, and you have 240 volt lines, which have to go to 120 volts to be further reduced in voltage. You can't plug something into a 10,000 volt line. That would not be good for it, or probably you either. So what does a transformer do? Well, a transformer changes voltage. That's what a transformer does. Changes voltage. So transformers, robots in disguise. Transformers, all right, they change voltage. They delta V. That's what I'm talking about, baby. Delta V. Changing that voltage. Now, you can increase voltage or you can decrease voltage. Sometimes you need voltage to be decreased. Again, you can't use 10,000 volts. Not in an outlet. It has to be 120. Devices are made for 120 volts here in America. Okay. So, or sometimes you need to step up the voltage. Oh, and I just said those words again. I keep saying them. When you have an increase in voltage, this is called a step up transformer. Step up trans. All right, step up transformer. If you have voltage going down, you're decreasing it from 250 to 10,000 to 240 to 120. That's a step down transformer. Okay, so when I'm talking about stepping up and stepping down, we're talking about changing the voltage, either increasing or decreasing it. That's what we're talking about. Okay, how's it done? Actually, it's quite simple. A transformer works very simply on Faraday's law of electromagnetic induction. Remember? Yeah, that equation. And here's a version of it right here. And we can see that the reason it's going to work, the reason you can change your voltage is because of that. The number of coils. Yes, the number of coils. That's how you do it. That's all transformers are. They just simply have more or less coils to change the voltage. What do you mean? I still don't know what you're talking about. Okay, let's say that you have a transformer is typically a loop of metal. Doesn't have to be a loop. It doesn't have to be a loop of metal. I'll give you a square of metal, whatever. But you've got metal, which of course we know conducts electricity. And you have a wire coming in. Here's your wire. And you spin it around, solenoid it. There's that word again. And this is one wire, but on the other side, maybe this, we have another wire. And maybe this one loops around. You got 4 loops there. 1, 2, 3, 4 loops. Here I have 2 loops. And here I have fruit loops. fruit. Fruit. All right. So here, that's a transformer. That's it. What the transformer does, it works on the principle of the number of coils. And so if you have electricity moving through this wire, and it can then, because this is metal, this is a loop of metal, and it can transfer that energy over throughout the metal. Of course, it conducts electricity. And so what will happen is that this loop over here, this is more loops, this is less loops. Now, if this is, okay, current's moving in this direction, whatever, and then we have, this is where the current's coming from. So the current's coming from here, and it's going to this. So here comes the electricity, and I'm going to loop it around. It loops around over here 4 times, and it leaves, and this is where I'm going to have it go do something useful that I want it to do. I need the voltage that this is going to generate. This is called a step-up transformer. Why would that be a step-up transformer? Because look at the number of coils that I have here on the left, and this, by the way, is called, if the electricity coming from here, this is where electricity is coming from, and then leaving, going to, this is called the primary. Okay, the primary coil and the secondary coil. If the electricity is coming from this coil, it's called the primary coil. When the electricity is going to go to, is called the secondary coil. If the secondary coil has more loops than the primary coil, we have a step-up transformer. This is a step-up. Why it's called step-up? Because what's going to happen is you are generating a certain amount of voltage, but then over here we're going to generate twice as much voltage. Why? Because there's twice as many coils. Direct relationship. And so here, I am now going to have 1, 2, 3, 4 coils. So if I have more coils in the secondary, I will generate more voltage out of that. That's how you step up the voltage. You can increase the voltage from maybe 120 volts to 240 volts or whatever you need it to do. What do you call that thing that heats the house there? The thing in the basement. Furnace. The furnace, yeah, the furnace. The furnace, just start a furnace, that takes a lot of oomph. Okay, you can't just, just plug a 1.5 volt battery in. Okay, start, go. No, that's a big piece of machinery that's going to go start to do its thing, right? So you need a lot of voltage. So there is a transformer on your furnace that it goes from, you typically have 240 volts to something which is using a lot of voltage in your house. Things that use 240 are those are the big plugs. The big plugs are like stoves, electric dryers. Those use 240. But that's still not enough to light that furnace, get that furnace going. That's a big room that we need. So you can you have a transformer there that steps up the voltage to 10,000 volts. And not every one of them, but the one at my house does anyway, 10,000 volts. And so that would be a step up. Now, a lot of times you need a step down transformer. The electricity coming from the power plants is very high voltage stuff, and you can't use high voltage stuff to plug in your hair dryer and get your hair all fluffy like mine in the morning. I dry my hair every morning. Okay, if I don't do that, it's out of control. It's out to here, out of control. So I have to plug in my hair dryer. 120 volts is all I need. So if you're going to use 120 volts, then here's the electricity coming from the outside, along the street. It's like 10,000 volts. And in your house, you need 120 volts. So this is where it's coming from. Outside your house into the home is where it's going to. And in this case, this would be your primary. and this would be your secondary coil. That is a step down transformer. Step down because you have more coils here, it would be a higher voltage. Here you have less coils, it would be a lower voltage. So this is a step down transformer. All right. So transformers are very simple. They just work on coils wrapped around a piece of metal. So the coil, the energy comes in, the current comes in. You've got a certain amount of voltage to it, transfers that energy to this line over here. It induces, it forces a current to move through here, and it will be moved through here depending on how many coils you have. So the amount of current that you get is depending on how many coils that you have, so therefore the voltage that is produced by those loops. All right, now, there are equations. You know that. Yes, you do. You know there are equations with this because it's physics, and that's what happens. We have equations that go with our transformers. Okay, so we'll stop this video, and then we'll pick up the equations on the flip side. All right, see you soon.